Hiya 10. So we're going to start this with just a little recap on the 5 key graphs that you need to know. So this first graph we're going to have a look at is it's just a linear straight line graph. So you should be very familiar with this in the form y equals mx plus c. So this m being the gradient, this c being our y-intercept. You should be very familiar with that. This is our quadratic graph. You should also be quite familiar with this. So it's in the form y equals ax squared plus bx plus c. So this a, b, and c, these are constants. So similarly to when using the quadratic formula, they're just any number, and it's going to, depending on what this a, b, and c are, this graph is going to change either location, size, scale, but it's always going to be this general shape. So you need to be able to recognize this shape, and then it's a quadratic graph. If this at the front here was a negative number, this a was a negative number, the graph would go the other direction. Okay, it would almost be this sad face instead of this smiley face. It would be the same shape. So you need to be able to recognize that as the quadratic graph. This is a cubic graph. So similarly, we've got a, b, c, and d. So it's ax cubed plus bx squared plus cx plus d. Okay, so these a, b, c, and d are constants. And depending on what these are, it might change shape a little bit. So sometimes it can flip and come the other direction, but you're always going to have this general shape. So this S or Z kind of shape, depending on how you want to look at it. So this is the cubic graph. You need to be able to recognize that. Down here, we've got the exponential graph. So y equals e to the power of x. So this one is also quite recognizable. One of the main features is that we've got an asymptote, it's called here, at the x-axis, so y can never be equal to 0. So this graph gets infinitely close, but it never actually touches the x-axis, and then it crosses over the y-axis, and it crosses at this particular one because we've just got e to the power of x. If we've got x equal to 0, we're going to get 1. So it crosses the y-axis here at 1, and then it goes up and it goes off into infinity, up to infinity. Okay, so this line carries on forever. Same way it carries on towards negative infinity this way, but no matter how far it goes, it's never going to touch this x-axis. It's never going to be y equals 0. Okay, and similarly, we've got asymptotes here on this graph. This is the reciprocal graph, so y equals 1 over x. So we've got, it's never going to touch the y-axis, and it's never going to touch the x-axis. Okay, but you need to be able to recognize this shape as the reciprocal graph. So we've got two distinct parts of this graph. But yeah, they both are part of the graph, and we've got two asymptotes again, like I said here. Y equals 0 and x equals 0, we've got asymptotes. Okay, so we're now going to apply our graphs to help us solving some questions. So we're going to have to look at some examples where we can just read answers off of graphs and see how they can help us. So when x equals minus 2, what is the value of y? Okay, so we're going to have a look. Here is x equals minus 2. So we can follow it down until it hits our graph. And where it hits our graph, we're going to follow along to the corresponding value of y. Okay, so we're going to get y equals minus 2. It's our corresponding value of y when x equals minus 2. Okay, so we're following on and following along. What are the three possible x values for y equals minus 2? So we've already found one. We already know that when y is minus 2, x is minus 2. But also we've got another point here where this graph crosses the y-axis. It crosses at y equals minus 2. So we know that another value, possible x value for y equals minus 2 would be 0. So x equals 0 is another value that satisfies this condition. And similarly, we can follow along here from y equals minus 2 in a straight line to hit our graph, and then follow it up again to x equals positive 2. So our three possible values of x that satisfy y equals minus 2 are x equals minus 2, x equals 0, and x equals 2. Okay, How many x values give y equals 0? Okay, so y equals 0 is obviously the line, the x-axis, so the line that follows the x-axis, and we want to look at how many times our graph touches that point. So it crosses the x-axis 3 times. So we know that there are 3 different values for when y equals 0. Okay, so that's just 3 there. When is x cubed minus 4x minus 2 more than 0? Okay, so this graph here is y equals x cubed minus 4x minus 2. Okay, so for this question, we want to see for what values of x is this graph more than 0. So is the y value more than 0? And we can see that that happens here and it happens here. Okay, so these two, on these parts, the y values are more than 0. So that satisfies the condition. In fact, this is quite a there's only a limited number of nice graphs, and I've tried to do a selection of questions here. So these points aren't you can't just read these points off. You will be able to on the questions that you're doing, if that's what you've been asked to do. But for this one, it's a little bit trickier because I've tried not to use the same graphs that you're going to be looking at, and I've tried to do a range of questions. So I've actually these points I've found using Desmos, which is a little tool. So we've got between minus 1.675 and minus 0.539. So that is our first range. So we've got x is more than minus 1.675 but less than minus 0.539. And we've got when x is more than 2.214, so this point here where it crosses. Okay, so these are the points where it crosses the x-axis.